2D contouring tips and tricks within PowerMill. The reason why we came up with this one for this month is because we did have some individuals struggling whether to use, 2D contour as far as 2D curve profile machining or even 2D features. Where do we split this up? And my answer to that is actually threefold. And as you can see here in the list here, I have the old way versus the new way, basically. And for all of those PowerMill users who've been with us for a very long time, and individuals like myself have been using it since the early 2000s, we got used to using 2D or creating 2D toolpaths using 3D toolpaths. That's because we didn't really have the tool sets for 2D chaining and things like that in the original versions of PowerMill. However, we have added those new toys to us. So during our presentation, we're going to go ahead and touch on all the different toolpaths that you can use. I won't go through every single one of them, but we'll go ahead and list the majority of them that are used on a regular basis. We're going to go through some different tips and tricks for those usages, including things like chamfering, key cutting, and traditional contouring. And we're going to use the 3D toolpaths to kind of start with the old method. And you're going to see some pros and cons as we go through this thing from the old way of doing things with using 3D tools, as well as to the new tool sets and kind of some case scenarios that we're going to be using. We're going to be kind of staying within one part for this. And as usual, everyone should be muted throughout the entirety of the demonstration portion of this best practices. But at the end, we will have a Q&A session. At that time, if you want to be unmuted, you can always raise your hand and we can get to your questions, or you can enter the questions within your question field in this GoToWebinar. So that being said, I'm going to jump over to our demonstration. And I just have a part here that's got some simple 2D features on it that we're going to go through all these different scenarios with. Right now, currently, I do have a block just shrunk wrapped to the entire the model that's set here in the project. I have some connection moves preset here just to speed things up, including just some start lead in, lead out, being that I'm working primarily with contour throughout this demonstration. It's just going to be horizontal arc with a little 90-degree with a little linear move there of a couple thou, so we can get to things like cutter compensation and things like that. Safe area wise, just to the block. And as we go through this, you're going to see the different tool sets in how we manipulate the block a little bit, especially with our old way of doing things, using some of the 3D toolpaths, how important the block can be to kind of getting 2D toolpaths very quickly on a part like this, on a prismatic part like this. With toolpaths, if I go into my toolpath strategy selector here and we look into our 3D toolpaths, primarily what I look for when I'm trying to do like a 2D contour is just this model profile toolpath. Model area clearance is somewhat capable of doing it, but because model area clearance is geared more towards roughing parts out and kind of looser tolerances and maybe with some remaining stock on it, it's a little easier just to use model profile for the start from our 3D aspect. And that's within our 3D area clearance toolpaths. Now directly below that, we do have our curve area machining, or curve machining, toolpaths that we use, and that's what I labeled as new toys on the previous slide that I was showing. The only reason I called it new toys is because after their release many years ago, they were somewhat new to PowerMill users at the time, and not really something that we looked at doing as far as our PowerMill workflows, because we were using 3D toolpaths for the most part. Now with that came the ability to use our 2D curve profile, which actually uses our patterns and uses edge chaining technology, basically similar to other CAM softwares. And that's why these were primarily released. Other CAM softwares had a traditional way of selecting edges and basing chains to create 2D contoured features too. Later then we came up with our feature machining capability. This was geared towards kind of a workflow or a process that was very similar to another Autodesk product, which is Feature Cam, where it extracts the surface geometry, similar to what holes have always done within PowerMill. We will touch a little bit on these features, and I'll give a little bit of tips and tricks with it. Features really need to be a webinar all on their own, considering they can be quite complex. Usage-wise, you're going to see a little bit as I go through the rest of the demonstration why I lean a little more towards using the other tool sets versus moving into features, but I will show you what features are good for, and kind of my preferred process to this, because there are some hangups in features that many users have already flagged that if you don't really go about the process quite correctly can cause, you know, instances where PowerMill might fail at them. So we'll kind of look at that a little bit, but like I said, depending on time, that could take a little bit longer of a subject matter. Now in finishing, we have several toolpaths that I like to use, particularly for specific things. And towards the end of this day, the end of our time here, we will be going through swarf finishing and kind of utilizing swarf finishing to even do 2D toolpaths. But other than that, we can go through a similar process with constant Z surface finishing that a lot of users, longtime PowerMill users, use this for 3D toolpaths, or 2D toolpaths rather, as well as profile finishing. So that's what all those are selected. I did create favorites, a favorite list here that I've starred and selected everything so that it does show up from my home tab here in my create panel. So you can see that the toolpaths are all populated up here that we'll go through within this demonstration. I'm gonna go ahead and close my strategy selector down there. To start things off, model profile. So under the 3D options, again, that's a more or less under the roughing options within PowerMill, you could say. I'll go ahead and click on my model profile toolpath. Now what this toolpath does, and this is again one of the more old school methods of doing things, all right? This is a 3D toolpath. It's going to basically project the toolpath around the model based off of the geometry and all the flat areas that it finds. It's going to project basically a contour around those areas. Now this does this around all of the model within the block region. So when we look at settings to set this type of toolpath up, block is one of the tool sets that is incredibly important with all of our 3D toolpaths. That's something that we do teach within our classes. I'm gonna go ahead and go to right view for this real fast, and I'm gonna select my part here. Actually, I could select that from my levels here. And I have a quick key that I'm just gonna quickly come in. I must have something selected out there. I can come in and shrink wrap a quick block around just my part. Now, with model profile and just the settings that are set, I don't have anything really outrageous here set here. I've just got a 1 thou tolerance for speed here during the presentation. I will bump up my step down here. Let's go ahead and select a tool. So I'll come in and select my 1/4 inch tool for this. This is a rather small part in a 6-inch vise, as you can see. And let's just go ahead and calculate this so you can see what it's going to do. It's basically going to find all the flat areas again and profile around those regions within the calculation. Now, I will make a couple of adjustments afterwards. We'll go through a few more settings with this, but this is a very fast way that you can come in and just calculate 2D toolpath around areas of your part. Now the block right now being shrunk wrapped to the surfaces, you can see does have a few hangups on it. So again, when I say that the block is the most important part here, that's what's actually limiting kind of the area that we're cutting in. Even when we have our limits set to outside of our block, as I do with my defaults, that still will cut the toolpath at specific spots. And you can see there's some regions here that are allowing it outside of the block and some that are not. However, if we just open up the block a little bit, we should be able to calculate that area. Now, one reason why this is very popular with users for a very long time is that we can be a little specific with this. If we just shrink our block down to a specific region, and in this case, I'll go ahead and just select a few surfaces here. I know I should put paintbrush on, but I'm not going to. If I just alter my block here, and then just calculate my toolpath within that region, I quickly get a contour around just that side feature there on that open pocket. All right, so it's very simple to come in and start creating this toolpath just based on that. Now I do have, it looks like I've got a couple of cut distance settings in here that may be coming back and doing some finishing or something like that, yeah, over the wall or something like that. That's causing an extra pass in there. But you saw how fast that was for me to come in and just select a few surfaces, shrink wrap a block around this, and then just apply that model profile toolpath. Now, some of the pitfalls that we have on this type of toolpath. One of the things that happens right away, other than leads and links, those are kind of trivial at this point. We can add those at any time with our leads and links settings. But what we do have is point distribution across the toolpath. Now, oftentimes the way this defaults within our points will actually be set up for traditional tolerance and keep arcs. All right, I'm going to calculate that with tolerance and keep arcs just so I can get that toolpath the way I need it there. And then I'll go into my toolpath and I'll turn these points on. That's going to assume lots of points around arcs that may be unnecessary for the machine to use. Particularly, I find this with like finite control machines or Haas machines. You're not going to want these points, or else you're going to get kind of faceted surfaces across all of your parts in these prismatic features. These are features we want to control a little bit better than that. So we can, of course, come in and set these features to come in and fit arcs to this. And as we do, that is going to change our arc moves and give us a little more control. And you're going to get better linear movements in between the arc radial movements of the toolpath. All right, so that's a better way to set this toolpath up for success from the standpoint of surface finish control, things like that. Those are things that individuals who use controls like hide and hide may not care about. Controls that eat points up for breakfast and then just love points are going to give you a smoother finish based on the look ahead functions that they have. So there is some functionality there that you do need to pay attention to if you do use model profile such as this to contour all around your part. I'm going to select my part real quick and we'll just do an entire model profile around this part. Let's go ahead and right click and select all here. And again, I'm just going to shrink wrap a block real quick. That's a special macro that I have that's set to a quick hotkey. That's a command, and the tilde or the squiggly line next to the 1 key. It's actually a feature from another software that I liked that I just applied a macro to. That's how I do that quick block region, if you will. Now, the nice thing about the block within PowerMill, especially once they added the edit capabilities, I can just double click on my block here and I can start pulling things out so that I can give myself a little extra room to calculate around the part. I don't actually have to be perfect. I do, however, want to pay attention to that depth. So again, that depth is going to control where my block is going to go. And if I want that to just be up above those jaws a little bit, I might pull that up and accept that. And then I'll go ahead and calculate my toolpath. Now, again, because we can go back and adjust features so easily in PowerMill, that's how we learned things a long time ago, to go back and we can edit features, or we can just delete toolpath that's unnecessary. In this case, I don't really need that pass that's up above on that top. So I'll just select that, come up to my quick access toolbar up here where I have delete set up here, my toolpath edit capability, and just delete what I don't want there. As long as that point spread is correct, I'm pretty well ready to go. Start and stop points, it's the same thing. If I come to the edit toolpath, I can move start and stop points for any given toolpath anywhere that I want and apply a new start point to it. Oops, I forgot to cross through the toolpath there. Always good to go to a top view when you're doing this. But as I do that, that should alter the start point. Oh, there's a lead in, lead out issue there. All right, well, let's go to one of the standard contours here, and let's put that towards the middle just for, there we go, just so you can see a start point move change there. I'll have to go back and alter that on the lead in, lead out to fix that back wall there. But you can kind of see how quickly and easy it is to come in and use model profile to get contours very fast. And that's why we utilize that. And that's one of the reasons why I showed this first as one of those tips for 2D machining. If you're just getting in quick and dirty, it's very, very easy to come in and just start applying this toolpath versus going in and having to apply any edges. I'm going to go ahead and recycle this real quick. Of course, we do have the ability to apply cut distances as far as numbers of passes with this. We can always add how many passes we want here and then calculate that out. And we're going to get radial passes out here for roughing or finishing, or even coming in and doing a quick a spring pass, if you will. I do prefer, however, to make copies of toolpaths for things like that because I like to separate things out in my NC program a little bit. But other than that, that capability is here, along with wall finishing and being able to come in and separate that step over for an individual pass. And you can tick last pass only. So we have lots of 2D capability in here, including cutter radius compensation applications, all right? So we can apply cutter radius compensation to this within ToolWare. I will actually calculate this. There may actually be a pop-up. I might not have a good enough lead and link on some of the profiles here. We shall see. Yeah. So there is some consideration to take in when you're doing this as far as suitable leads and links go. You want to have the ability to lead in, lead out appropriately, and usually that can be a few factors that can hang that up. One of them being not having a correct linear move in there, or not having the horizontal arc set quite correctly. Sometimes that hangs this up. And of course, I do have an overlap distance set here that I have by default. Let's see if that recalculates. Yeah, I would have to play with that cutter compensation to get that to work just right for me. But we have that ability and capability within the 3D toolpath, and then we're not stuck kind of finding each individual flat region every time we want to make a toolpath. So that's one of the reasons why we would use model profile as a 2D toolpath. Now moving on to our next kind of 3D option, we can look at profile finishing. This is basically doing the same thing. Most of the time, I wouldn't necessarily use this for 2D, just simply because this is basing itself off of the projection of the outside selected surfaces. This does give you a little bit different control as far as what you're actually profiling. Instead of profiling everything within the block region, this should just focus on what we've got for the selected surface, but it is going to project around every edge of those selected surfaces. Now, the nice thing is it does project it down onto the surface for us. And if my point distribution is set to fit arcs, I should still get a fairly clean toolpath out of this. I'll come into my toolpath here and show my points. Of course, I do have some cap surfaces that I didn't get the top of the chamfers for, so I am seeing some areas here that I would want to delete out of that region. But basically, this does give us the ability to not have to shrink our block down to a specific size to be doing that. Let's see, I have a question. So with questions, everybody, until after we get, if you can remember it, or if you can write it down for right now, we'll actually go to unmute everybody at the end of the webinar, and then I can answer questions at that point. All right. Okay. So moving on, just kind of pointing out that model profile as a capability. You can see there, added the toolpath to us there. Let's go ahead and move on to our next solution, and it's going to be the constant Z toolpath. Now, I'm going to show constant Z a couple of different ways. With constant Z, it can be used very similarly to what we did with model profile. It's going to find steep regions. There might be some tweaks that we need to do to be able to machine our steeper regions. But I'm basically going to come in and just grab a couple of surfaces here once again and shrink wrap the block down to a region. I'll go and just calculate this. This is going to have steps to it. And you can see now that I've come and I've contoured a part using just constant Z. And many users, simply out of ease of use and using constant Z for a surface finishing toolpath, do this all the time as a finishing strategy for 2D geometry. So if I go into my toolpath here and click on points, you'll see I'm getting nice arc moves, and that's because of my modal default from toolpath to toolpath here still fit arcs. Just keep in mind that the standard default for these toolpaths are set to fit arcs. We can set things up for macros and also save things within templates that help with all these settings and keep these settings set. Now, I did do a webinar a while back on template objects and template files, so there's a lot of information on that previous best practice regarding those. Now, that was simple and easy to do. Where I find leveraging constant Z versus the other three toolpaths there is I actually find it within chamfering parts. So I'm going to go ahead and recycle this toolpath and just come in and simply change my cutter. And I'm going to do I think I've got a Harvey or a helical. There we go, 45-degree cutter here. Just to come around the chamfer of my parts here. And I'm going to show this two different ways. We're going to do this both on the sharp edge as well as on the already chamfered region here. I'm just going to come in and I'm going to select my chamfer set that I've already set up here. So if I select all on those surfaces and quickly shrink wrap a block once again, you can see I've got my block region shrunk wrap around those chamfers. Now, if I just simply by calculating this toolpath, I'm going to get a complete chamfer region, and the contact point of the tool is what is actually going to drive the tool path for this, right? So it's always going to come in contact with the surface around the constant Z. So if I come into my tool path here and simulate from that point, you're going to see that the chamfer is contacting directly to the tip. Now, again, our block tool, our block is kind of the master of our depth here within 3D toolpaths. So if I needed to adjust this and choke up on the cut versus being directly on the tip here, it's very easy for us to come in, edit the block after I've opened the settings, and adjust that down. And you can always do this accurately within the block settings as well. You can come in and set your Z within your block and just adjust your Z a little bit. But after I've actually set the block just a little bit lower there, I can calculate this, and that's going to choke up on the toolpath. You're going to see the toolpath come down a lot lower. Simulate that. It's choking up on the part. Now I went a little too far with that, but you can kind of understand how that works. Just to fix that block real quick. Let's choke up on that. And I don't think I actually recycled my toolpath first. There we go. Again, being a little more accurate, this helps. Now, the reason why I'm showing this is because these are kind of toolpaths that we can do automation to as well. So we can apply these techniques to macros where we utilize selected surfaces, whether that's either in sets or levels or even by color within a model. If you select to have features colored within your model, we can actually apply a block to that region, an extent to the block automatically, and calculate a constant Z toolpath and chamfer all of your parts. Now, I'm going to go ahead and just grab the top of this surface here and clone that toolpath. And I'll shrink wrap this block up to the top there. I'm going to go ahead and pull the extent down just a little bit for the example here. There we go. I'll accept that, and I'm going to calculate the toolpath just so you can see it calculating around multiple pocket regions on this part. So it's basically finding all of those areas. Now, if I simulate that, again, the toolpath is going down to the bottom on the constant Z. The contact point for the tool is the exact edge. Well, a lot of users just simply come in, and this is more of a trick than anything, and just define a negative area on your thickness for both axial and radial. Once you calculate that, you will get a red toolpath if you have automatic collision set. However, you will also be, as it is gouging the part, you'll also be chamfering that by that 10 thousandths, giving yourself a nice 45 degrees on there. So rather funny. It's a nice fast way to come in and start chamfering around features on your part. Go ahead and close that out. You can see that the red exclamation mark, that's because the cutter really is gouging into the part. Now, there are some things within verification that we can do to kind of ignore that if necessary. There are some tricks that we can do with verification that help with that, or even within the surfaces if you need to get a better scenario out of the gouge check. But other than that, you can see how quick this is to come in, get toolpath just on every single surface that we may want to chamfer. All right, go to my home tab real quick. Let's go down the line here. So that kind of covers a lot of our 3D, as far as our 3D solutions that I like to use. Those are the most popular things that users have used over the past years to get in and do things quite quickly, as far as 2D works for prismatic features. Now, let's take a look at some of our new toys. And within our new toys, we're going to start out with all of our some of our curve machining options here. And again, this is focusing on 2D profile. Really, 2D curve area clearance is good. It is a decent tool set for clearing out large areas in a 2D fashion. However, I believe that features are actually a little bit better at that. We won't be covering that too much here in this presentation. However, we will look at our 2D curve profile. Instead of using the shortcut, I'll just double click to start us out within that toolpath. So this changed the kind of the game as far as 2D goes for PowerMill users. And when we teach 2D within our classes, we typically migrate to these solutions for curve profiling, just as an example of 2D. We don't really show a lot on our 3D side of it anymore within our training. However, that's why I wanted to do this this best practice, is to kind of show both sides of the coin here and some scenarios where you may or may not want to use it. Now, this is a more traditional type of 2D contour toolpath where we're profiling around specifically chained edges or features. That being said, geometry within PowerMill is basically set up with either patterns or boundaries. In this case, these toolpaths tend to use patterns. So we're going to go ahead and create a pattern. Now, I do like the workflow of creating the pattern within the toolpath. This does tend to help on a couple of different fronts. One, you're focusing that pattern for this individual need, which helps a little bit within the process. I will change my tool first and foremost. Get back to our 1/4 inch in mill here. I will grab my part and just contour or create a block around my entire part. Just my block there. Now, in the pattern of this toolpath, once I go ahead and create a pattern, I will go right into my editing of the pattern. Now, there's lots of different ways we can select and pull patterns into our project, depending on the surfaces of the part or what we're actually going to contour. To start things out, I'm just going to grab the bottom surface of my part. Now, we can do a collect. I tend to like to focus things a little bit heavier on the other options within PowerMill. I will go ahead and do all of these real quick. Let's just collect that real quick so we can take a look at a collected pattern. Now, the key to these toolpaths and the success behind these toolpaths, and we'll just delete what we don't want to use here. I'm just going to get rid of all these pockets. Once you have a pattern, I always like to tell everybody to click on the instrument. It's important to click on the instrument. Now, whenever PowerMill extracts curves around surfaces and features, it's basically making a decision based on those surfaces and what those tolerances are that are set up within the project, okay? So what's important to note here is that we're looking for nice, clean point separation across the entire part. We can also see kind of a marker that's showing us directionally what direction the natural direction of the pattern is. Now, this all helps with setting 2D toolpaths up successfully from the start. With that being said, you can see I've got good, nice point separation across here between my arcs and everything. So that collect is a decent way to grab the kind of pattern. Now I'm going to go ahead and hit accept this and create another pattern. Show a different method just so we can get a little more out of this. Oftentimes when you're looking at parts, there might be scenarios where you have to get a profile that isn't quite flat, or maybe there's a feature that you can't see. Well, you're going to use different methods to collect those surfaces, or even maybe use a different method like a planar sectioning to be able to pull that. Now, this is more of a trick. What this basically does, and you just need to make sure that your plane is set within your system's toolbar down here. Make sure that you're set to your Z plane for your XY. You can see you get a preview of that plane. I'm going to go ahead and select the surface that I want to go to in Z for that plane. Go to a front view real quick. There we go. Yeah, it's automatically ticking on my front view whenever I do that. Sorry. You'll see the plane. I need to lock it. There we go. Go to my, make me a liar. Sorry about that, guys. There we go. Basically, to see where I'm at on that plane, and maybe I need to bump this up just a little bit. You can see it's a few thousandths out up off of that. So if I basically bump that plane up and then hit my preview, I actually get a preview of the sliced profile area that I'm going to be extracting for this. All right, so with that, I can turn my geometry off and you can see what I'm going to extract out of there. So I'll go ahead and create this. Now, again, once you create that pattern, it's important to come in and turn on your instrumentation. You can see without even calculating a toolpath, I'm going to have tons of curve geometry. That's because that slice option is going to pull curves off of the sliced edges, all right? It's projecting those out, and they are 100% splined curves that are in there, right? So there's a lot of geometry that's in here that's unnecessary. If we were to calculate a toolpath to this, you're going to see a lot of very bad, you could see a lot of very bad faceting within your toolpath. I mean, there's different situations for different machines. However, we kind of want to clean things up a little bit with this. Now, I like to point out that when we do this, my next little trick here, there's a couple little hangups when we try to fit arcs to this or fit the spline to this. And I'm going to go ahead and do this real quick. We'll just go ahead and fit spline as our first example here. And I'll say fit spline by 1/1000. All right. What this does is areas that aren't sectioned correctly within your pattern might end up actually turning into curves. And in this case, we do have one of those here, which within 1/1000 you can't really see that. But if you're working on something that's tight tolerance or accurate, you'll see what it's done here is kind of turned that into a curve versus a straight line. All right, so it's important to note when you check your pattern, check your instrumentation, we're looking for these extra points. We're looking for those abnormalities within that fit of that curve. Now, sometimes you can up the tolerance of that. I've had an instance here recently where when I did that with ARC, PowerMill decided to just sit and think about it for like an hour. So you do want to be careful selectively. And one of the ways I work around some of those calculation issues is to actually come in and separate these out before I apply either a curve or an arc or any fitting options within the pattern. All right, now that's a lot of work, and I do agree with that. So we do know collective works a little bit better at first on this. Now let's go ahead and just demonstrate that real quick. I can just come in and cut, grab my sections where I want to make sure that I separate things here. That way I can select something. I can say, okay, well, let's change that to an arc fit on that selected surface. And that's going to allow me to adjust that. Now, had I done that to the entire model, and I'm not going to do that for the demonstration, to the entire pattern, that actually would have sat for like an hour trying to calculate. There seems to be something wrong with that arc fit option there. But that would clean it up, and then I just simply need to come in and merge everything together into one pattern again, right? And I would need to do the same thing up here for my radii in order to clean these up. Just segment that out. But again, this is a lot of work. You know, this isn't the preferred method. This may be something that becomes necessary at times, depending on geometry, right? So we have all the options within PowerMill. We're not short any options here. I have had some new users come in and ask questions about some of these different pattern options, like similar to contouring and something other like other softwares. But once you've cleaned everything up, the key here is just to come in and merge those together. Now I have one pattern. I do see that I'm going the wrong way. Now this is more of a, I would say user-based preference. I really don't like the pattern going in the wrong direction of the cut. So as I know I'm climb cutting with this, I might select the pattern and reverse that selected so that this is going to start in the right direction whenever I come back into my profile options. Now profile options, let's go ahead and go into our machining selection options here. So on the right hand side, the pattern itself does not drive the curve. Now you'll see there is a successful pattern here. Part of me starting the pattern direction in the right way helps with this so that I don't necessarily have to go into my curve machining options. Now this is similar to chaining options and all other softwares that are out there. Once I'm in here, you'll see that I have a little end mill that kind of indicates where and the direction of cut that I'm going. You'll see the arrows kind of in my climb cut. You'll see that the end mill is on the outside of the part. If you click on that, it is interactive. That does flip your directions on your curves. The nice thing about this is I can also change the start point, and we can move the start point to a different location. When the ball is kind of connected, it snaps kind of to itself here. That's going to kind of change where the start point of the curve is. And basically, you see within the ribbon interface up here under the edit panel, you can see that we can change the different selections. So if there are multiple curves, this works with multiple curves. You can also see that we can reverse the direction here. That's basically the same thing as my interaction within clicking on it. And then I can accept that region and it would calculate. Before I move on to calculation, I will show one more trick as far as pattern creation goes. So I'll create another pattern. We'll go into pattern 3 here, go into my pattern edit options. And that is the composite curve. A lot of people might use the composite curve to be able to extract edge geometry. That's basically all it is doing. I'm going to go ahead and select my edge that I want to extract, and this is very quickly going to be able to tangentially stay around that part. You can see I can reverse the direction here. Now, one thing I like to point out when I do this, be very wary if you hit that fast forward button. It is going to want to naturally go by default to the tangents. However, if there are any surface deviations that are outside of tolerances in your composite curve tool, you're going to start seeing this thing go all across your screen. It is a good idea to create start and stop points within the composite curve. Now I can create a video on the composite curve if needed, and it has been kind of thrown out there as an option for one of our quick tips. But with that selected, I'm going to hit OK to that. And again, I'm going to turn on my instrumentation and just turn off my geometry and make sure that my points are correct, and I'm not going to get a whole lot of spline geometry on there. It can happen if surfaces aren't very well translated into PowerMill. The other reason it can happen is if the composite curve picks the wrong surface. So when we launch the composite curve tool, it is making a decision between the different surfaces. And if I cancel out of this, I'll be able to select the surfaces. So we have two different edges. It can select the edge of this surface down here on the floor, or it can select all of the edges here on the side. All right, now depending on tolerance settings and your surfaces, the composite curve could choose to jump the gap between the two. I have seen this happen in some rare occasions on customers, and they're wondering why they've got so many points or splines instead of actual arcs and lines within their pattern. That is because the composite curve tool is extracting the wrong geometry. All right. Now, in order to avoid this, the simplest way to come in and select these items is just grab the surface that you want to focus on, use an old school method of blanking, and I'm going to hit Control Y to do the opposite there, but Control K to blank accept. And once I have that blanked out, except for what I want to actually select, I can go in and use the composite curve tool, select that edge. It's going to snap itself chained all the way around. It just has one selection to find. There is nothing else in the way. You're going to have an easier time selecting your geometry with the composite curve tool this way. All right, and you'll get nice clean chains out of that pattern. All right, I'm going to hit Control L to bring my model back. Now, anyone who doesn't know, and for newer users, just so you know what I just did there, I'll go up to my view options here. This is blanking and unblanking options within surface selection in PowerMill. When I select something, I can choose to blank that selected surface, which is the Control J I did, or I can blank accept, which is Control K. And then you can toggle between the two, which is the Control Y that I did. And you can see that those shortcuts show up when you hover over that. But just for newer users that may not know these techniques, I'll throw that out there. And that's all I did to focus that profile selection there. Now, if I come over here to my curve machining and my machining selection, sorry, I'm going to show a few other things, a few other options that are in here. The nice thing about this is that we can come in and grab one of our patterns via any of the methods I just shown. And let's say I needed to focus just the toolpath around this region. This is more of a traditional way to control the chain. You saw that I moved my start and stop point. Well, I can easily come in and move my start and stop point to different key points around these features. So I can come in and snap these within points here. And you can see that actually the start and stop point for climb versus conventional was off. So I do need to reverse that. There we go. So that my little end mill icons are on the outside. But now I'm just going to create toolpath on that selected region of the curve on my pattern. So I can come in and move those chains around. So you can be a little more focused on what you want to do within this profiling. And that's one of the reasons why Curve Profile is a better tool set versus what I was doing with model area clearance. I mean, it's really tit for tat. It's up to you as a user what you want to use and what kind of results you're looking for. And also based on geometry, what you're actually going to be machining. You know, that's what it comes down to at the end of the day, what we're looking for, how you want to machine it. Now with these 2D toolpaths versus our 3D toolpaths, one of the biggest thing that this does is this actually limits itself based on the absolute selection. All right, so coming from my active work plane based on the absolute selection. So what I did here is I grabbed my surface selection tool and I just grabbed that bottom surface. That's going to give me that Z height. So no matter what I do in calculation, that's going to give me a toolpath at that Z height. Now that's one of the reasons why this is a little bit more focused, and it gives us a toolpath just for that individual feature that's selected within the pattern at that depth of cut. All right, now the other reason for this is that we can go lower based off of the depth absolute versus trying to manipulate the block to create that depth distance. All right, so that's a big thing with these curve profile machining versus our 3D. 3D is automatically doing it versus per the surfaces. Our 2D gives you that selection and gives you that choice. All right. With that, I'm going to go ahead and hit OK to close that out. Let's go ahead and just quickly take a look. I mean, there's lots of different scenarios on this part that I can go through, and maybe in QA, if you guys have extra questions about that particular tool set, I can cover that. Again, once we're in our question and answer time here, we can kind of take a look at anything you guys got. But let's go ahead and just touch base on some time we got here and get into just our feature profiling. Now, I'm going to go ahead and go back into the strategy selector to show the difference in the features versus the curve. You know, once we go into curve machining, you'll see an orange icon usually inside of the graphics preview that you get here. And in features, you're going to see a red colored. It's actually purple, but reddish purple, depends on your screen. But it's purple on a feature that shows up. Now, before I jump into the toolpath here, you can see there's many different toolpaths depending on the features that you create. All right, so again, this is a webinar in itself, but we focus on profiling here in a second. I'll show you how we can do and select the profiling features. I'm going to cancel out of that. A lot of users want to migrate to creating features right away. I tend to steer users away from this, all right? So there is some automatic feature recognition that can happen within PowerMill. It is not fully developed, in my opinion, intelligently enough so it can go its own on a part. And that's my opinion. I know other users may be able to use it in different ways, but I have had this crash more times on me than not. So I tend to steer users towards doing this within a toolpath similar to how I did it within a pattern. Now, I do like using these toolpaths occasionally because it does allow itself to create a feature that automatically finds open regions within my machinable features here. All right, so in this instance, I'll show you where we can come in and grab the feature. And again, I like doing this per the toolpath. Keeps me focused, keeps the feature focused as I apply it to the toolpath. I don't have to go in and activate or make sure things are active at the time. This is going to apply it directly within there. So I'm going to create the feature group first. And that's important to note. It's very much like our drilling toolpaths, where it creates a group of these features first, so you can contain many of them in one. Then we'll come in and we'll actually create the feature. So I'm just going to go into the feature editor directly here. Okay, now, if you have many pockets at this point of similar features, you can use the feature detection tools to do that. I don't recommend doing it. It can be time consuming, and it can also cause some crashes if you aren't careful with your selections. Okay, again, that's got to be a separate webinar because there is some complexity to that. But when I'm doing contouring on side features, that's simply what I'm going to choose. I'm going to come into my 2D feature creation here. I'm going to choose that side feature option here. All right, now there's ways that this can be extracted within a profile that's defined basically by a pattern, or I can come in and do surface selection. And that's what I'm going to do for this. 90% of the time, I'm going to do surface selection. I'll come in and I can start selecting surfaces. I don't have to hold shift down for this. I don't have to have paintbrush active. This is all assuming that I want to select these surfaces as I go around the features. Okay, so just as a kind of a preview for our features, so you can see what it's done is it finds those surface edges. I get the top and bottom for my depth, and then I also have this open area that's already predefined for this contour. All right, now that that's already set, I can apply that and accept it. There's my purple feature that you can see, but I do have to come in and make an extra step here and accept the feature. All right, so it's very important, or else you'll cancel out of the feature and it won't actually exist for you. Once that feature is there, it is not yet selected for machining. So this is an important step that a lot of users just start coming in and defining the way their cut conditions for this. You have to make sure that you come in and select it. Now there's an exclamation mark here kind of indicating that that's what we need to do. And if I hover over that, there's no feature selected. It's just a matter of selecting the feature, either in the graphics window or here in this feature tree. Once that's selected, okay, now I can start defining my cut features that I want to define, right? Like my step over as well as my step down. Whether or not I want to have multiples, I'm just going to go ahead and untick that for this toolpath. It's based off of the previous toolpath that we created. And then with this, when I hit calculate, you'll find that that's going to calculate itself to the feature depth, but also give me kind of an outside profile area that allows for a little bit of lead in around the selected features. All right, so features are pretty good at doing this and managing it. It's just about the selection that you use for it. Now, like I said, this is a case scenario, a usage case scenario, where if you want to control this feature well, tolerance-wise, or to print rather, features have actually been really helpful to me for those use cases. Okay, with that, that's kind of my preview into features in themselves without going through another hour-long webinar on it. And if that's a request that everyone would like to see, please let me know. You can let me know in the comment sections here or even in the question sections. If that's something everybody would like to see more usage of features, we can go through some of that. It is easier, of course, to use 3D. I won't dance around that. The 3D toolpaths make everything a lot easier when it comes to this. But for control and finishing in particularly, that's where I find myself using features. Roughing out direct to 2D and maybe defining a little more area for the feature. I do that a lot too. And there is some editing capability. If I double click on my feature here, there is some editing that we can do. If it's unlocked, we might have to copy it and unlock it, that we can actually pull this out and give it more area for the approach. So again, that's something I'd show in a separate webinar. The other way we do that is actually by extending our cut within our leads and links. So just real quick to touch on that, extending your leads and links is kind of one of the better methods to do that, just because we can do it to every toolpath. It's not necessary to have it focused on an individual toolpath for a feature. We can actually give this an extension in and say extended move, and I'll just give it a 1/4 inch for that. And then I'll extend the move out. Now, of course, I want to do that after my my lead in, lead out, but you can kind of understand how that works. I would actually want to do this the other way. Let's do the extended move. And let's do a horizontal arc for this. 90 degrees. There we go. So we can extend those moves out a little bit more if we need to, just based off of that extension. Moving on, just as with the time we have here for the day, I'm going to go ahead and jump into swarf machining and just show some swarf machining. Now we can do the contour options basically as we've seen them based off of the profile options that we've shown with the 2D curve profile machining. You can, of course, do undercut features with that as well. However, I'm just going to show this with the swarf machining just because it's fun to kind of come in and show that we can do these things in swarf machining. So if I come to my finishing options here and I come to my swarf finishing options, people always think of swarf as a 3D or 5-axis toolpath rather. Really, it starts out that way within our tool axis, but if I just create a template that has this set to vertical, this kind of forces things out to be 3D. Now, the nice thing about this is it will do multiple surfaces if I want to, and I am going to choose a key seat cutter for this, just for our demonstration purposes here, and it's going to do both the inside and the outside areas on that surface. The nice thing about this is I can preview kind of the cut before it happens, so I can kind of get a preview of the cut that's going to occur. I am going to calculate this real quick based on the preview that I get. You can see I get a nice swarf around those surfaces in that region. I did limit things with my block once again. I'll go ahead and calculate that. And I'll get that swarf that's inside my block area. So if I need to get things outside of the block area, you definitely want to open your block up a little bit for this technique to work. Now, I do this a lot when I have many boss features or many and mostly inside contour features that I would be using like a key seat cutter for. I like swarf for this. It's more or less just kind of my personal preference. Mostly it's just like the way the toolpath calculates, and I didn't recycle my block for that, so oops, my bad. And I don't really care what this is. I'm just gonna give it a ridiculous size block. I always smack preview Just to remember, see, I didn't actually have my surfaces selected, so I'll select those, and then I'll recalculate that. Now, gouge is also taking place here. So this is an instance with an undercut. I might come in and untick gouge just to calculate, to make sure I get a preview of the toolpath, see what it's going to do. You'll see that I get the successful swerf toolpath all the way around it. But that's a 2D, feature being machined with our swerf toolpath. Now, the other reason why I like using swerf, again, is multiple features, such as the pockets that we have here. So I'm just going to go ahead and shrink wrap my block around my part. I'll go into wireframe view here, and I'm just going to select these pocket features. Shrink wrap the block around those. I'll change my cutter so that I can get a successful slot out of this. Let's go to this little tiny 1/8 inch end mill here. I'm going to go ahead and go to my block real quick and lock my Z up and expand this out so that I can successfully get around those parts or those features. Once I have that, swerf again, I like to smack preview, see what I'm going to get. Once I have all those features here, I'll just come in real quick, do a leads and links change for this. So on my lead in, lead out, this is actually going to be pocket center safe, pocket center, sorry, and I'll calculate my toolpath. Now, a lot of users, and I have inside versus outside here, I imagine. Oh, it's just got a feature outside of the block I must have selected. Yeah, there's some failure there, isn't there? Let's just delete that real quick. Oh, I do need to set up the surfaces there that it's seeing. It's getting a little mad about my my cap surfaces there. So let's just grab my cap surfaces. I skipped a step on you guys. Apologize for that. Let's grab those, bucket those into that selection, apply and accept them. And recap. Whoops, that's going to be bad. Looks like I accidentally misselect there, so I deselected my surfaces. Yeah, bonehead move on my behalf there. Start looking at that clock counting down on me here. There we go. Let's deselect the bottoms. That way we can be successful here. After I get through with this, we'll go into QA. But I do want to show some other compensation options here. All right, so with our cutter compensation options, we have the capability of applying compensation to toolpaths that don't actually have compensation. And for old school users, we know how to do this. It's actually within the NC program itself. Once we apply the toolpath to the NC program, the toolpath itself actually has options within here for compensation. Now, the downside to this is that you don't get the preview option. So if your lead in, lead out isn't quite correct and doesn't have the extent to actually apply the lead in your code, cases for Haas and for some Finite machines in most cases, then you won't actually get that. But once I add that compensation, I'm then able to turn that on, and then that will post out in code separately. So we'll have cutter compensation on our swerf toolpaths, if you will. So I mean, just some usages that I like to do for some 2D, different 2D examples, how to do different contour selections. It can get more complicated than what we had time for to show this afternoon. But hopefully you guys kind of get some ideas in your head. And anytime you apply these and you start to use them, guys, feel free, if you run into any issues on any of these techniques, give us a call at NextGen Cam, or just come and go to the website, create a ticket, turn in a ticket. We're happy to help anybody out.